Everybody, and welcome to a much anticipated OpenShift Commons briefing on my part. I've been waiting for the MapD folks for a while to do this, and I'm thrilled to have Veda Shankar with us, and he's going to talk about how to deploy MapD on OpenShift, specifically the Community Edition and Origin. I'm going to let Veda introduce himself, and he'll have chat. In the chat, we'll do our Q&A, and then we'll have live Q&A at the end. So take it away, Veda.
Yeah, thank you, Dan, and thank you, Red Hat, for the opportunity. Really excited to be here. I'm Veda Shankar, and today I'll be talking about the MapD Community Edition deployment on OpenShift Origin. I'm part of the community team at MapD, and you can reach me at veda.shankar@mapd.com. And I'll make sure that this deck is available on our speaker deck before the end of the day. And so today, this is the agenda for the webinar today. First, I'm going to cover MapD so that you get an overall overview of exactly what is MapD, how is it used. I'll also do a quick demo of one of our data sets, and I'll also show you how you can actually try the same data set at your home or office, and you can spin up your own cloud instance just to get familiar with MapD. Of course, MapD can be deployed on-prem or in the cloud. Just like OpenShift. And so we'll do the MapD overview, the demo, and then I'll go over the OpenShift deployment. Of course, I just wrote a blog which has been published on MapD site, and I'll put the URL in the chat, so that way you can actually drill through the details, and then we will actually try to do a live demo. That's always a fun part. So we'll have two demos. One is the MapD, and then the other one with MapD running on OpenShift. Okay, so we know that most organizations are now, data-driven, and that keeps growing. And with the large amount of data, companies really want to extract as much value as possible. Now, for extracting, for doing the analytics, you need computational power. Now, the computational capacity of CPU, which is primarily used on most platforms, is like growing at best at 20%. And the data itself is growing at 40%, so the gap is widening. And on top of that, data is getting richer. It's getting multidimensional in nature. So we have location information like geographic coordinates. So it makes it even more challenging, more compute power needed. Now, in addition to the challenge with the hardware, the right folks, who have the ability, we also have the analysts are ending up, downsampling the data. So they're trying to, because they don't have adequate capacity, what they do is they resort to things like pre-aggregation and pre-indexing, which are actually harder to scale, especially when you're talking about millions or billions of records. And also downsampling will result in missing outliers and long-tail events. Now, so what's the solution? The solution is GPUs, which are constructed quite differently than CPUs. Now, GPUs actually have thousands of cores instead of tens of cores on a CPU, and this is particularly important, when it comes to dealing with large, data sets. And also the performance of GPU is increasing almost 50% year over year, addressing the computational gap. MapD was designed ground up to basically harness this parallelism that is inherent in GPUs. And so it enables to run your queries and also visualize them on really massive troves of data. And these are basically multi-billion row data sets where you can get your query results in milliseconds. So this is almost like 100 times faster than any other product in the market. MapD consists of a columnar database. We call it the MapD core, and that supports SQL. And there's a command line console, and also you have connections to major programming languages, and also it has ODBC connection. Now you can have a MapD core installed on a single or multi-node configuration, and it can support up to 8 Nvidia K80 cards. Now on top of MapD core, we have MapD's visualization platform called Immerse, and Immerse basically leverages the power of MapD database to provide like complex data visualizations. So what you'll see is both very complex charts along with simple ones, all in the same dashboard. So how is MapD so fast? We call it as extreme analytics. One of the reasons is we have heavily optimized some of the SQL analytic operations like the where SQL command, which is used for filtering, and group by, which is used for segmenting, to run as fast as possible. We also use something called as LLVM, which allows us to do just-in-time compilation. So that means when you send a query, we actually create an independent, like an architecture-independent intermediary code, and then depending on the backend, whether it's CPU or GPU, it'll finally execute on it. And you will see today that we actually will be able to launch a Docker image both on CPU or GPU. Now, this approach of compilation is actually very, very efficient in terms of the memory bandwidth and the cache space utilization. And that's where we get our millisecond response time. Now, with the MapD Immerse, which is the visualization platform, what we do is we have very complex, data-rich, with geographic information charts like choropleth, and at the same time, you have very simple charts like line, bar, or pie charts, all on a single dashboard. So this basically gives you a multidimensional insight into complex data sets, and you're able to discover patterns which was not possible, especially in real time. Now, how do we do this? Where we are able to gather, we are able to take in this billions of rows of data and still render in milliseconds. The way we do that is using something called Veda's visualization specification language. So we use that, and we send the query to the back end using the specification. And because the query results are residing on the GPU, we use the GPU to then render those complex images, whether it's like point maps with polygons and things like that, or choropleth. Now, once it is rendered on the GPU, then Vega sends back a PNG image, which is typically in hundreds of kilobytes. And so within just a few milliseconds, it comes back to the browser, which is then able to render it. Now, for the simpler charts, it is rendered by the client, the browser, and so that way we're able to present everything in a single dashboard. Now, as you can see from this chart, the, the memory bandwidth between your storage layer, which is your SSD, to the CPU, to the GPU, there's actually orders of magnitude difference. Now, and we actually make use of this GPU memory to also achieve our response time. Now, we try to keep as much hard data as possible in the GPU memory. And so that way, your query times are actually much faster. Now, what you'll see is that because of this computational power of GPUs and also the memory bandwidth of GPUs, the AI folks are slowly integrating GPUs into their machine learning pipelines. Now even if you're using GPUs in your machine learning pipeline, when you are actually passing data between different applications, you will actually end up kind of going back and forth, serializing and deserializing data between different applications because they are in different binary formats. So to avoid that, Go AI initiative was started. It's the GPU Open Analytics Initiative, and MapD is a founding member of that with other companies. And it basically allows you so Go AI actually, the first project created a GPU data frame, or GDF. It basically allows you to efficiently interchange data between different processes running on the GPU. So all you need to do is just pass this pointer, which is pointing to the GPU memory, and so there is no copy in and out. And the Go AI basically uses the Apache Arrow columnar memory format as the data layer. And as you can see, MapD actually fits in very well with the machine learning pipeline. We accelerate the the feature engineering process, basically allowing you to identify the features that are important. We're also, because of our visualization, we're able to kind of explain what those AI models are doing by visually showing it. And also at the same time, when you have predictions and you have the actual outcomes, you're able to compare whether your predictions are in line with your actual outcomes. So more and more, MapD is becoming an integral part of any machine learning pipeline. A month ago, and actually we launched MapD 4.0, and with 4.0, we actually support geospatial data types. So that means we can actually support any of these geospatial objects like a point, line string, polygon, multi-polygon. And so these are native now in the MapD database. So you can actually run SQL statements that can use functions like stdistance, stcontains, which on this data set. Now this is kind of helps you in displaying this information. Now where we were used to be able to do like just 5,000 polygons using the front-end rendering, now we can actually do that. Like we can almost do like 1 million polygons on a billions of row data set in the order of milliseconds. So who are our customers? MapD has customers that includes telcos, capital markets, advertising, oil and gas, federal utilities. So it covers many verticals. And most of these organizations are data-driven, and so they use MapD for operational analytics to actually drive real-time tactical decisions when the data is coming with high velocity and this high volume data. So if a company like a wireless company is wondering why the phone updates go bad, or if they're determining the patterns in cell and Wi-Fi data, and all these have a geographic component to it. So it's very easy to kind of find those patterns and get really good insights into your data using MapD. And this can be done interactively. Excuse me. Now, so finally, we have like very good stories from our customers. Happy to share them offline, and how businesses are actually adopting MapD to basically sleuth around with the data that they have, and it becomes like MapD becomes an integral part of their the data exploration pipeline before they feed the interesting data points to their AI or machine learning pipeline. Okay, so it's demo time, and I think I'm doing okay on the time. So let's go to.
Yes, you are. You're doing fine.
All right.
Yeah.
Now, before I jump into the to my instance, I want to tell you that I just want to show you that it is really easy for you to just go to mapd.com, and there is a try cloud button. Once you click on, all you need to do is just enter your email address, and you get a 14-day trial of an instance in the cloud with GPU. And so you'll end up with a screen something like this, and so you'll end up in a screen like this where you can launch MapD, and it'll launch your instance in the cloud. Now, once you're in the cloud, this by default actually comes with a few data sets. One of them is the flight database. This is all the 7 million flights in 2008. Sorry, I have a big clutter here with many, but you have a few, like a taxi data set. There are a few data sets that are preloaded on your cloud instance, and they also have dashboards like the taxi rides or New York tree census or the flights demo. So if you click on the flights demo, for example, so this is how a typical dashboard looks. And as I was explaining, you have complex charts like scatter plot, which are using 7 million. In this case, this is much smaller compared to our typical customer, which are in hundreds of millions or billions of rows. Now you find a scatter plot, a choropleth, and then a heat map, again, along with simpler charts like line charts and bar charts and a table. So in the first one, for example, you see the departure delay and the arrival delay plotted out, and you see almost a straight line. And this is expected when you have a delay in departure that you will arrive late. But also it's color coded based on the airline. And we'll actually do this chart on the GPU. Just wanted to give you a quick idea. And then here in the choropleth, you'll notice that you can actually zoom in, and you can hover over here, and you'll notice that the state of Illinois and state of New York actually have very similar, arrival delays by destination. You can also, have, flights by month and day of the week. So here's the month, and here is the day of the week. And you notice, based on the color patterns, that blue means very fewer flights, and on Saturdays, really, as to be expected, is quite low number of flights taking off on Saturday. Now, you also have a line chart which shows based on the the time and the number of records. Now, you can also kind of drill down over a smaller period of time by simply using dragging on the lower the scale, and you can see that you have actually selected a much smaller window. And as you, the most important thing is, as you are selecting a certain column or a certain time frame, it gets applied across all the charts that are derived from the same table. Now, you can actually combine multiple tables and multiple layers, and that's a different topic. But that is the beauty of MapD, where I do a select on this on these fields, and it immediately gets applied to all the charts, and it all happened so fast, with the blink of an eye, that you'll see that every single chart got updated. So, for example, if I click on United Airlines, you will notice that everything got updated. Now, from the 7 million records, you have like 26,853 for this time period. And you can always clear the filters and go back to that. So it's a very powerful tool. So now, next, let's see how we can get this running on OpenShift. Okay, if you go to mapd.com blog, under blogs, you'll see that you have the article that I just posted, and I'm going to put this URL in the chat window later on. This basically goes over how I deployed MapD on OpenShift. Now, OpenShift, of course, has a much multi-node, with gateways and Bastion servers and basically. So what I did was I wanted to have a very simple deployment with just 3 nodes, one master and a couple of nodes, and specifically like 1 node with GPU and 1 with CPU, just to make sure I convey it. Of course, you can scale it out depending on your deployment. And I found SysDig's tutorial to be very useful. They actually have a CloudFormation script, which I borrowed, and I kind of modified it to launch this setup where I have a CentOS running on a T2 medium, and that's going to be my master. I have another CentOS running on a P2 extra large, which has a Tesla K80 GPU, and so that's going to be my GPU worker node. And I have on a T2.large, that's going to be my CPU worker node. Now, they're all part of a VPC, and I also opened up the ports with which we'll be communicating. Now, in addition to that, I also attached an EFS, an elastic file system, because I just wanted an NFS share. So I just created an NFS. Now make sure that when you create that NFS, that it's part of the same VPC, and it belongs to the security group. So that way you can communicate. Now I know OpenShift actually has some great native storage solutions like GlusterFS and Ceph-FS, so you can actually use those products also for your storage. Now, I went to the OpenShift, Ansible GitHub project to basically get the playbooks, and I used 3.9, and it just so happens that OpenShift 3.10 just got released. I think yesterday or day before. But hopefully these instructions are still valid. Now, and then I ran through the playbooks to prepare the environment. And one important thing is to, of course, fix the host inventory file to reflect your setup. And again, these instructions that are chronicled over here are applicable for both cloud, and this could be any cloud, or your on-prem deployment. So once you run through the Ansible and everything is okay, you should be able to create an admin account with a password. And one way to kind of smoke test if everything is okay is to just log into your web console, OpenShift web console. Now, most of my instructions are using the command line OC tool, and so that's what we'll do. Now, after you verify whether your nodes are okay, then what I did was I labeled the nodes. So I made sure that I label it as CPU and GPU. So that way I can launch the MapD Docker image either on depending on what I want to do. And but at the same time, in this particular scenario, I'm sharing the same NFS share folder for both my GPU and CPU instance. I mean, you can actually separate it out, but in this case, I thought it was pretty cool to point to the same database, albeit it has to be on separate nodes and not at the same time, right? So that way, if I have to do some loading and creating the tables, I'll use the CPU version and keep my GPU version powered off, and just to save some money. And then once I'm done with all those tasks, then when I want to actually go and run the queries, then I can fire up the GPUs. In fact, I can even use the CPU version for creating the charts, but then for actual querying, then I can use the GPU. That's when I really need the computational power. And now, one important note is the Nvidia driver installation. So this was a little bit involved on the CentOS, and so I documented all the how to install the Nvidia driver, the container runtime, how to set up the hook and things like that. So once it's all done, you need to reboot and make sure that the Nvidia driver module is mounted, is loaded, and you can also confirm that through NVIDIA-SMI that you indeed you can see the GPU on the system. Then what I did was I created, deploy MapD GPU.yaml, and in this case I'm just deploying a pod. Maybe in another blog I'll show how it can be started as a replication service or a deployment where you have many copies of the pod and you have an HA configuration. But this is a very simplistic one. I define the pod and I specify the node type is GPU, and this is the Docker image. The CE Community Edition CUDA stands for the GPU edition, and we are mounting the NFS under /MapD storage. Now these are the ports that are exposed, and then we finally launch it. So now let's go and try to run through this exercise. Okay. the connection broke, so I'm passing my PEM file, and then I'm going to log in to the master. This public IP address. And if I do an OC get nodes, you should see that I have a master that's in a ready state. Then I have two compute nodes. They're also in ready state. If I want to know which node is what, I can say OC describe node, and if I select that one, you will see that this is of type GPU. So the .12 is the 10.10.00.12 is actually the GPU node. Just remember that. The .5 is the CPU node. And if you say OC get pods, so these are the Docker containers that are running. Now, by default, these are the OpenShift management Docker containers, the registry, the router, that's all running. And also the OC get service, you'll see some of the services that are running, including Kubernetes and the router. So let's clear that. So I'm going to use the first launch, the GPU version, and I'm going to and it says OC get pods should now should basically point to the MapD container starting. You can actually do a describe. And also confirm that it indeed got launched on the right GPU node. And okay, so I think it should be ready to go. Get pods. If you're doing it initially, it might take some time because it's going to be pulling the image. I'd already pulled that image, so that's why it is little, it's very snappy. And the next thing is, let's make sure that now that we know it's running on the 12, I'm going to do an SSH. So this is the actual node that it's running, and I'm going to run the Nvidia-SMI command on it. So now this is a pretty cool command. It's got a lot of options that will be very useful as you play with the GPUs. So first is you notice that it has the Tesla K80. You notice the memory utilization of the GPU, very important. That will tell you whether the amount of GPU memory is sufficient or not. And also you notice that in the process section, you see that the MapD server is running. Now you can actually log in to the pod by simply saying OC RSH MapD, and boom, you're right there. So if you do a df-h, you'll notice that the NFS share is actually mounted on /mapd-storage, which has the database. And so if you look at d-storage, it has the data. Okay, now what we do is we bundle this command called, we bundle this called insert sample data, and I'm going to run that to actually insert a table into the database. And just because of the time, we're down to like 32 minutes. So I'm going to select 2, which has just got 10K, rows instead of the 7 million. But at home, you can try with a larger data set. You can also try something much larger, hundreds of millions. And it's going to be inserting it. It's pulling the CSV file over the net and inserting it. Hopefully it will be done in a few seconds. Okay, it's done. And next, what we'll do is I'm going to fire up the MapD command line utility, and it's called MapD/in MapDQL. And the default is a database called MapD, and this is the default password for it. And you can see that it says user MapD connected to database MapD, and you can say /t to list the databases. Actually, I should have done this before we imported. So when you initially do, you get your Docker image, these 3 tables are already there. These actually have the polygons for the different counties, countries, and states. So that way you can do a join when you have your own data set. So that way you can draw the choropleths and those kinds of charts using geographic information. So we have the flights data set, and you can describe the data set by saying /t flight. And it's got quite a lot of columns. And actually in the blog, what I've done is I just put just the columns that we will be using in our query. So for time, what I've done is I'm trying to do a cut paste of this query that I saved. So it's basically select the origin city and the destination city and the average airtime, and you're basically grouping it by the origin city and destination city where the distance is less than 125 miles. And so if it's moving the data from the NFS share, through the CPU to the GPU. So that's why the initial delay. Now, if I run the command again, it's almost instantaneous. Now that it's initially loaded the columns that you are operating on, now any further slicing and dicing of those columns are going to be in milliseconds. But the initial load is going to come from your persistent storage, and you will see much longer query time. Okay, so we have been able to successfully look at that. Now what we're going to do is, now that we can look at it from the command line, let's see if we can create the same the scatter plot that we saw in the demo. Now let me quit from the database, and I'm going to control D. One other thing is Nvidia-SMI. you can also type that on the Docker, and you will see actually now that the memory utilization actually has gone up. Okay, so I'm back to the master, and if I do an OC get service, I have the standard ones, but what I'm going to do is I'm going to launch the MapD service, and as you can see, in this case, we are starting a service and we are exposing the port 9092 as 30092, and it's using the node port service. So in effect, the port 30092 is going to be available on every single node in that cluster. So even though I can also use the public IP address of the compute node or the GPU node, even though it's running on the GPU node. So let's go ahead and create the service. So now that it's been created, going to go to okay. So here's my EC2. So I'm grabbing that public IP for one of the nodes, and I'm specifying that, and along with 3092. Okay, so you just go here. And voila, we are in. And if you go to the data manager, we should see our flight 2008 10K. And you click on that, and you notice that there are 10,000 rows with 56 columns. And so now we can go ahead and do our dashboard, and you can click on the new dashboard, and you can click on add chart, and you need a source for the which is a table. So we'll select the flight database table, and then in the so you have two things. One is the dimensions, and another is the measure. So first, we're going to select what kind of chart do we want. So we want to create a scatter plot, which is right here. And so as I was mentioning before, you see a combination of pretty complex charts like point map, geo heat map, choropleth, all of them using geographic information and rendered in the back end by the GPU. Whereas you have all these bar, pie, and line charts which are rendered on the front end. So we're going to select the scatter plot, and we are going to use the measure. In this case, we are going to choose the departure delay, and then we are going to choose the arrival delay. And you notice that it immediately renders it. You can also choose a color palette to decide what else you want. Basically, the difference between the measure and the dimension is the dimension is the categories. So this is typically your row label in a table, and the measures are actually the aggregated values, like the sum, average, and all that. And this is basically a column in a table. So now, once you create the chart, you can say apply, and that creates it. And then you can, give it a title, my chart or my dashboard. and do a save. So this way you can actually build on this. So we have 3 minutes left before I want to open up for a Q&A. So let's see if we can quickly go back to our terminal. I'm going to delete, OC delete service, and then the name of the service is MapD service. Likewise, I'm going to say OC delete pod, and the name of the pod is MapD. Of course, the termination takes a few seconds, so let's pause. While it's terminating, what we're going to do is I'm going to do a cat of deploy MapD CPU.yaml. So this is the YAML file that we'll use for deploying the CPU. What's the main difference here? The main difference here is the node type is CPU, and the image that I'm going to use is MapD Community Edition CPU. We are going to use the same mount point coming from our NFS server. Okay. So let's do a get pods, and it's gone. So I'm going to say OC create -f. Let's create it. I'm also going to create OC create. Let's see, OC get pods, and it's and we can do an OC describe pod MapD, and we should see that it's actually mounted on the CPU node, which is the 10.0.0.5. The .12 was a GPU node, and this is the one that is marked as CPU. And okay, so no wonder it's taking time, because I think the images got updated. We, by the way, have a new update to our Geospatial that was launched yesterday. So it looks like we have a newer, Docker images. So it took a while to pull. Okay, so that should be in a ready state now. And it says running. So now I can say OC create -f MapD service.yaml, and so service is created. So in effect, I should be able to go to the same. I should have shown you that it was down before I did it, but let's see. If I go back to the port, hit enter. So I do see the same dashboard that's there. So it's running on the CPU. Oops. Aha. Okay. So this is a good point. So when you go to help, even though it's running on the CPU, you have to notice that when you're running in the CPU mode, some of your complex charts are not available to you because they require backend rendering, and you'll notice that the backend rendering is disabled because you're using a CPU version. So, so the product is actually primarily used, where it really shines is with GPU. So that would be your default, deployment method. The CPU is okay for doing some of the simpler, charts and, actually doing some of the ETL operations. So that's 46 minutes. So thank you. And Diane, I want to open the floor for any questions.
Well, this has been an amazing demo. I mean, I'm a big fan of MapD, and really thrilled to see all the work that's going on. I'm not seeing any questions, so if people have questions in the chat, there's a bunch of people who have been listening in. please pop into the chat and ask your question or just unmute yourself. I know yesterday we did a briefing with Jeremy Eder on that had a lot of GPU content in it as well, and I know that literally right now they're inside of Red Hat, we're looking at how to automate all of some of the CPU and GPU enablement. So there's more to come, and I'm definitely going to hook you up with Jeremy and Zvanko, who did yesterday's talk, to have a further conversation, because I think there's quite a lot to learn. If you could put your last slide up and share your screen again, just so we know how to contact you, that would be great.
And also, I'm going to put the URL, the URL for the blog in one.
Perfect. So there's a lot of people on. I think you might have stunned and amazed quite a few of them.
And
you put the query in. That's good, but definitely cross-link to the blog post when I post this up on YouTube and on the OpenShift blog. So I'm looking to see if there's any questions. I'm curious to see if there's other people who are already using MapD who are on the call or who watch this video, and if now they're thinking of deploying on OpenShift, if they could reach out. I'd love to see and hear, get feedback on it, both for my the engineers working on OpenShift and for Veda. Sure, we'll have lots of.
Yeah, and definitely, Diane, if you could encourage folks to check out our community, very active, community.mapd.com, and we'll definitely help address any questions that comes our way, and we want to work more closely with Red Hat. And I see a lot of overlap and a lot of synergies, both open source. So I think I'm sure we have a great story to tell. Also, the mapd.com/cloud. That's where they can get a free trial. Don't be perturbed about the 14-day. Anybody with a good, valid use case and good intentions, we would love to work with you. We can always extend that. And give you even a beefier instance. So happy to work with anybody wanting to use the product.
I'd also give a shout out to the Machine Learning on OpenShift Special Interest Group, which meets the first Friday of every month, and tomorrow there will be one. If you go to commons.openshift.org and look at the events calendar, all the details are there, and we have lots of each week we have a couple of folks give very short presentations, and there's a lot of discussion about different use cases and best practices for running these ML and other workloads on OpenShift and Kubernetes. So there's some great conversations that continue in onto tomorrow and the first Friday of every month.
Oh, first Friday. Okay, wonderful. Good timing. Okay, I will definitely chime in then.
This is I try and stage the conversations the week before this event so that it's all kind of ML-ish and GPU-ish, and there's lots of going on. Yeah, so we'll get there. So again, Veda, thank you for taking the time. Folks, please do reach out to Veda and MapD and the MapD community, and if there's anything we can do, we'll do a follow-up when we get some of the automation working for the GPU and CPU stuff, and I'll definitely have you guys back on to do further deep dives on using MapD, and hopefully we can get one of you who is using MapD in production to share your stories as well. So it was delightful to see this working so nicely on OpenShift, and thank you again.
Yeah, thank you. Thank you. Have a wonderful weekend. But I'll definitely be dialing in tomorrow. Thank you.
Awesome.